Hello friends, welcome to part 3. In today we are going to discuss how objects and classes are treated in the assembly level. So as we all know, the assembly level in assembly language, it does not have a concept called classes and objects. Rather it's like static instruction set and it handles the memory. So here, today's discussion, we are going to discuss how our object-oriented programming techniques are treated in the assembly level. So this video is connected to rather our next series. So this video is more related to our next series of videos where we create the trainer to actually change the assembly instructions in the process rather than locking the memory addresses. But without this video in this series, we felt that the series won't complete. So that's why we decided to include this video right here. So before we start, I want you to play this game. This is a very fun game. So, basically, you have an enemy and a player. So this is so much fun. So what you have to do is you shoot to enemy, and you can see the enemy's health gets reduced, and you can shoot your player, and player's health also gets reduced. As you can see, player's health is reducing much quicker compared with enemy. So you can have a friend with you and you can play this game with him. So you tell him to shoot you and you shoot him and he shoot you, back and forth. You can shoot, but eventually your health is reducing much faster. That means you will be die soon. So uh, let's take this one as our reference to discuss the classes and objects, how they are treated in the assembly level. So first, before the discussion, I am going to scan the memory addresses using our memory scanner. So this is our progress bar here. So I don't know the initial value in the progress bar, so I am going for unknown. So first up, we are going to open the process, and since this is a 32-bit integer, so we know this is 4 bytes and the value is not known. Therefore I start the first scan from here. So I shoot to player, right? So now it's decreased, so I go for decreased value, scan. So I have decreased values much more and decreased. So without clicking anything, I am going for unchanged value. So my values gets reduced. So still I have more values. So I'm going for unchanged a couple of times, and I go for decreased value again. So let's go for decrease. Okay, I can see 97, 97, 97, and I see these values cannot be taken as a candidate values because this won't fit to this progress bar. So seems like these things get changed, right? But I'm going to leave this one. I can see that this value gets changed and again switch back to 96. So here I select all of these 4 and I click the manual add button, and I have to find the value, the correct variable from these values, these addresses rather. In order to do this, I am going to pause one by one and see who is going to change. Okay. Alright, since this one won't work, and let's see other one. It one also won't work. So as you can see, other variables get changed. Despite this one is 91, others reduced to 73. So let's shoot. Still, these values get reduced despite this one is 73. Now this one should be the correct one. Right, that is the correct one, because as you can see the progress bar won't, it tries to change, but when it refresh with this value, it again goes up. That's why the progress bar reduces and goes up. So if I increase this, you can see I get the full progress bar and it's freezed. So let me delete the other values from here. Okay, now in this discussion we are going to discuss the assembly code a bit. Not every assembly instruction we encounter in the x86 architecture, rather the assembly instruction we encounter through our journey will be discussed in detail. Alright, now to check the assembly code I am going for the instruction that writes to this address. Okay, so now this attached to debugger, now it's wait for some instructions to fill this write this memory variable. So if I shoot this, you can see this instruction. So I'm going to stop this. This is the instruction that we want. Okay, let's discuss about this instruction. This instruction says move the value in ECX, the right side from the comma, move the value in ECX to contents of the EDX. You see, this two square brackets means you should go for content. So for now, let's forget these square braces. Okay. So let's see the value of the EDX. So EDX in this sense is 00288058. So this instruction says move the value in ECX. The ECX value is also here, so it is 00063. It's in hexadecimal. So move 0x63 to the, not the EDX, the content of EDX. So it's look like this. So let me get my notepad here. So whenever you have an instruction, let me get another instance. Okay, this is my assume this part is my memory RAM, or your physical RAM. So I have address like this, 1 2, this is 1 2 3 4. So 4 byte means 32 bit. So this one contains the value 43, and please do note that memory addresses won't start from 0 in the real life. Okay, so we have memory like this. So these are your variables you declare as int. This could be int a, int b, and this could be int c. Okay, so all are in 4 byte alignment. So that is because int takes 4 bytes, so 32 bit. So this is int a, int b, int c. This is your memory. Assume this as your RAM. So in your RAM you have 43 in first address. After 4 bytes you have 56, and after another 4 bytes you have 22. So here assume this one is our processor executing instructions. So it the processor has registers, mainly they are EAX. In 32 bit there are EAX, EBX, ECX, EDX, and there are segment registers. And in 64 bit one, EAX becomes RAX, so all now E registers become R, so RAX, RBX, RCX, RDX, and there are a couple of some registers to R, I believe R50. There are a couple of registers like that. So now we are interested in 32 bit. So EAX register is our main register, EBX secondary, ECX must be the counter, and EDX. So as you can see, they are named as A, B, C, D. No E. There is no registers called EEX or REX or EX. There is a register called ES, ESP. ES means extra segment, but we are not going to discuss the segment registers here. And so this is your processor executing instructions, right? So let's see now. Processor encounters and instructions like this. So move EAX comma 0x00, or rather this is 30 bit, another 2 zeros. Okay, now 2 3 1 and 0. So 4, that means 32 bit. This means move 0 to the EAX register. So after this instruction, let me after this your EAX is 0. So assume this one won't execute. So this is like a comment. So here your EAX is now 0. But if you use like something like this, sorry. Now this one has a different meaning. So here, once you execute this instruction, your EAX register gets 0. But here, after after this instruction is executed, the content or the memory location given by the EAX register is going to be 0. So the memory location provided by EAX register becomes 0. So this one acts as a pointer. So this is the basis of the pointer. So the memory location, memory address is contained in the EAX register. So assume that I am going to read the value this memory location. So I'm going to use the EAX. So first I'm going to move the EAX to 0, 1, 2, 3, 4, and I'm going to read the value in EAX to EBX register. So I'm going to move EBX equals contents of EAX. Now EBX is equals to 43. Right now EBX 43, that is because contents of the pointer in EAX points to here, and now that value copied to EBX, right? So let EAX be in the same 0x0000. If I execute this instruction again, so if I copy and paste here, after this instruction executed, these locations become 0 0. Right? So that's how these contents one work. Here also we have EDX. So oops. So same as like this. So our EDX, let's see, our EDX is here, this one. So if I in now my memory segment, let me delete everything here. Let's focus on our this thing now. So in our EDX I have 002A8058. So in my memory RAM I have 002A8058. it is equal to, I don't know, something. Let's see, 22. Now no, not this one is in decimal. Now I'm decimal, not in hexa mode. Here this instruction, oops, right, let me delete the other one. Here we have move the value is in ECX register to the memory location that provided in EDX register. So our EDX register is this. So our memory location value is here. So it store the ECX value here. Whatever the value in ECX, now after this instruction stored here. So let's see our one. So this is our first state, and also here our first state after the instruction. So 2. Now here in 2, second stage. So this value is equals to ECX value in ECX. So after that, this memory location, that means this memory location gets updated. So after that, the progress bar updated and everything gets updated, right? So I'm just going to close this one. So instead of EDX, so if I click this again, so instead of EDX, why this one, this memory location, so we can use this like this one too. We can use the same, we can write the same instructions like this. So this says move EDX to ECX, okay? So why they use EDX here? Why we can't use this address? So this one is saying why we can't use this address. So this is saying, this is also saying this, go for this memory location and write the value. But why they use a register rather than the direct pointer? Now we are come to the place, the classes and objects, because C++ is a object-oriented programming language. So that object is represented as the memory location or the pointer by this address. You see, this program is written in C++.NET. You see there are two parties here, player and the enemy. Alright? The player and enemy has the same attribute, so they both have the health and they both have the functions to reduce the health. So this player and enemy are derived in the same class. So there may be a class called, let's say, entity. So entity class is the blueprint for this both player and enemy. Alright? So in C++, there will be two pointers for player and enemy. Both are constructed from the base class entity. So now we know the player and enemy are the instance. So we can check this, alright? So we know now this is the instruction that affects the player, alright? So what I'm going to do is now, this is the, so I'm going for showing this assembler. So I'm going to break this instruction, or rather replace this instruction. Okay, I simply double click this and I copy this and I put in OP or NOP, that means no operation. This code won't do anything, just skip through. and you say the generated code is 1 byte long, but the selected opcode is 2 bytes long. Do you want to replace the incomplete opcodes with knobs? So you should click yes. If you say no, this will break your program by breaking the alignment, so your program crash. So I clicked yes. So after we replace this knob instruction, our value, the memory variables value won't get changed. So if I shoot here, notice nothing happens. But there is a problem. If I shoot to enemy also, that memory address won't get updated because that's object oriented concept. So player and enemy both are instance of some class, and that some base class or blueprint has the method to reduce the health in both players and enemy. Now that method is removed, or rather we change, so it affects every object in the same base class. So now let me replace it. Alright, now we have it. So you can see now it works perfectly. So these are now two different objects in the same class. So why we cannot use this notation? That is because when we are learning object oriented programming, so there is a concept called a code reuse. Alright, so you have your class here. So you have your class. So these are your variables. So let's say int a and int b, and so under this you have your methods. So decrease or whatever. And decrease, increase, and method like that. So these are your methods. When you create an object, so this is your base class. So if you create an object from here, so if you create an object, it also has these intas. Oops. So it also has something like this. And let's see, this is our var variable star a1 equals this. So this is our object. So this will be your object here. Oops. So this is your object here, and also you can create another object. Well, let's see. So from here also you have this. So this will be your var star a2 equals this one, right? So if you execute the increase method on a1, it will affect these two. Or if you execute the increase in a2, it will affect the values in a2. Alright. Now to achieve that, the assembly instructions. So assembly instruction, as we know, it does not know anything about classes and object. To handle this one, it uses these memory pointers or memory locations. So this is pointer with the help of registers. So let's take about, let's get this instruction. So this instruction moves the value in the ECX register to the contents that provided in the EDX register. So here the EDX value can be changed according to player and the enemy. So player has one memory location and enemy has one memory location, but all are doing the same thing called reducing their health. So that one can be done by just using the base pointer or the pointer of the actual player. So here, if we go to the assembler, if I right click this one and find what addresses this instruction accesses, so if I shoot to player, I have one memory location, and if I shoot back, I have another memory location. So as you can see, these two objects share the same instruction but with different memory location. So this is the basis for object-oriented programming. So this is how assembly handles the object-oriented programming. So it all done by changing the memory locations using registers. Here, these two, this is our player and this is our enemy. So as you can see, the enemy has a higher number of health than the player. So that's why you see this one, the player's one is increasing faster than the enemy, but both are decreased by 1. So that's how the objects are handled. So basically it's look like this. This memory variable that we found, this memory variable in this case, so get this program as the reference. The memory variable in the player is affected by only one instruction. So memory variable and the instruction, there is a one-to-one relation. But as we saw in the assembly, this debugger, this instruction affects player and also affects to enemy. So this instruction affects multiple memory variables, memory locations. That means there we have instruction to memory locations, one to many. So that's how, that is the basis. That's how objects are treated in the assembly level. They compile methods as static. So all your methods are in static instruction sets, but with the provision to access the memory location via registers. So it uses these kind of square braces uh, to access the content of the memory location that provided in the registry. So they use a register inside of a square brace. So that is the basis for object-oriented concepts. So basically it differentiates the data only, not the method. Basically it differentiates the data. It separates the data in the memory, but the functions used to manipulate the data are same. So let me demonstrate the concept that assembly that we discussed in C language, how it achieved. So similar thing happens in the assembly level also. So you can get any idea. So I'm just going for create a new project here. So here I'm going for C++. Here I'm going for just console app, but I'm going to use C code rather than C++ code. Let's see, let's leave some name here. Okay, just remove everything. I don't want any of these. So here it says CPP. I'm going for C. I ignore everything because I don't need the IO stream also. So I'm going for C, so we have the better understanding from that. So in C, I go rename this as C. Let me check the compilation here. Looks like we have no errors. Alright, the program is exited with code 0, that means we are okay. Now, let's write a program like this. So first I'm going to include stdio. So make sure I have a printf working. So let's see. Right, it's one test that's working. Now, let's declare some structs. So two variables, two attributes, age and height. So since I use the type def, I can directly declare here. Right. This is one does is this create a object rather in C++ or Java. We can say that this create object. So in basic terms, this allocates the memory for this structure. The size of the structure is so here we have 2 ints, the 32-bit, so 4 bytes and another 4 bytes. This means 8 bytes. So 8 bytes of memory space to this structure and get that memory location to this P1, this pointer. So for initializing, I can use P1. So you can use P2. Sorry, P is still P1. So this is my initializer. So I'm going to create another object, same, right? So for this one also, I can use P2, age is 0, and P2's height is also 0, right? Now as you can see, for every person I create, per one person I have to use 2 instructions, alright? So in object-oriented programming, it uses single method for affect the data for that object. So that is what they call code reswing. So here in C also we can use the same thing, right? So this is how the actual thing happened in assembly language also. So as you know, C is also not a object-oriented programming language. C is also just as assembly language, it doesn't support object. But the way assembly language treats to object-oriented programming is they used different objects in memory, so allocated memory spaces to that pointers, and they use same instructions to affect those memory locations by using registers with pointers, okay, the square braces. Here also we can do similar thing. So here if I use a method like void init, right, so I'm going to request a person object, person structure, person pointer, okay, P, right? So here I simply can use, or I can use P, its age is 0 and P height is also 0, right? Now I simply can call, I can remove this everything. So I can use init P1 and init P2. So here in C++ or another object-oriented programming language, so you can see this as P1.init P2.init or the constructor. Alright? So let's see the compilation. You can see we have no errors here. Alright? So let me increase this value and let's see cheat engine. So how that assembly code is generated. So it's also should be similar as this one. So that is because this is how the assembly instruction generated. So in C also we are doing the similar thing as the assembly instruction generated. So if I have, let's say I have a method like void increase, right? So again I am calling for a pointer. Okay, so here I use p age equals or double, just plus plus, right? Now also I have another method. Right, so here now I'm going for value also. So I have p age is equals to value. Oops. Right, so this is for distinguishing purposes. After I init it, so I set age for person 1 to, let's say, 20, and let's say 26, and so I'm going for a while loop here. So this one won't work, we have to use 1. So here I'm initially prints the person's ages. So I go for P1 age here and P2 age, right? So here let's increase the age. So in object oriented, if you use classes, you have something like P1 dot increase and P2 dot increase. But in CV, since we don't have classes, we use this method. So the idea is the generated assembly instruction for this one, this code, this program should be similar to the assembly instruction that generated in our C++ class. So let's see whether it works. All right, let's use so the get char is the method that we are going to use. So once we press enter, the person's values ages get increased. So here person 1 age is 20 and second one is 26, so 21, 27. So now let's see whether our assembly instructions are generated the same way as our previous C++ program. Alright, so in order to do that, let's go to the cheat engine program, our memory scanner, and I know the first variable and second variable, so it is 26 and 27. So let's go from a single variable 5. So I have 20 and 26, so I go for 20, so it's 32-bit. So this one is written in C. So one should have, so next one should have 21, but I cannot see any changes. So what's going on here? Okay. I believe the problem is, so this should be now 23, now it's increased, okay? So this is 23. Now it's, this is the value, right? So here. That is because once we printed, the value get increased. So this one is just for printing purposes. After that 20 is 20 going to 21. So here I have 29. So if I change this, let's make sure that this is the one. So if I make it to 0, alright, so that's the one. Alright. So if I attach it to debugger and search for who's writing, so I have, again, you see, same kind of similar instruction. So move the content, move the value in ECX to content of EDX. I believe earlier also we had the similar instruction. So I believe we can open 2 instances. Right, we can open 2 instances. So let's see the instructions here. So we have this address. So I believe we have to go for right now. Earlier, remember the player's health is around 82, whereas the enemy's health is around 182. So that means this progress bar must be started from 100 and this is must start from 200. So let's search for 100, shoot to the player, and it should be 99. Shoot back to player. So right, this, and I know this is not the correct one because I saw this. You see this change. You see change. Right. So let's see one lock one. This one. No, not that. And let's see this one. Not that one either. Let's see this one. Not that one either. Let's see this. Yeah, this is the one. So if I check the instruction, you see the same instruction. In fact, I believe the registers are also same. You see 890, the instruction are both are same. So if we in this process, so this is our second process, so let me move it aside. Oops. Actually, let's minimize this everything. So if I go to the assembly, showing this assembler, if I put a knob here, this is our second process. If I knob it, so if I, you see, both the person's age won't change. That is because this instruction is changed by, sorry, this instruction is used by these two addresses. So if I correct it now you can see all are increased. So this is how objects are treated in the assembly level. So you have instruction or method, your actual functions methods. So the instructions that change or manipulate data are compiled as static, but they have the flexibility to access memory locations as registers and go and change their values. So similar to this, so your methods, this is your two classes, or they are in memory, they allocate memory for your data, not for method, and your methods are compiled as this. So in this case, method your method is compiled as this, so it accepts the pointer. So multiple pointers, so multiple memory variables can be passed with the same structure. So your data treated as structures, but the functions are compiled as static. So in C++, we can simply assume like this. So your data in the classes, so your variables, your ints, chars, strings, bytes, everything, it virtually create a structure for this class data, and it compiles the methods of the class like this. So it accepts the structure pointer that generated in the compile time for your class and manipulate the data in that pointer. So that's how the assembly level treats the object oriented, same like this in the C. So in next bonus video we are going to actually patch the exe code using assembly language. So next bonus video we are going to actually write some assembly language, but not to the trainer level. We are not using a trainer, but we are directly patching the exe executable. So the player's health is no longer reduced by this shoot, but the enemy's health is reduced 50% in one shot. So if I click this shoot button, this get to somewhere here, and again I shoot, it goes to 0. And if I shoot the player, it won't produce anything. So in next video, that's a kind of bonus video. So that should be fun, right? So you actually write the assembly code to your exe file, and from that you patch your exe file to save your player and instantly, almost instantly, kill your enemy. So that's for today's video. So that is how the basic object oriented programming, so object oriented concepts, handled in assembly language. So in future videos, not for as this series, so for this series we don't need the assembly code and stuff. So for just for fun, in future series, future videos, not in the series, I'll show you how the method overriding. So as you know, in object oriented programming, you can override methods. So in runtime, it binds to the correct method in the base class, sorry, not base class, subclass, derived classes. So in future videos, I will show you how the method binding in runtime works. So method overriding. So I hope you enjoy this video. So if you have any questions, if you don't get anything of this video, if you don't understand anything, just please put a comment. Your each and every single question, please put in a comment. So I will do answer everything, every single comment. So as I said in last week also, I want you to get this one very clearly and correctly. So therefore, please put your questions and your doubts and anything regarding to this in comments. So I will answer those. So thanks for watching this video. So if you like this video, hit the like button and give us a thumbs up. And please comment what do you think about this video series. So give us a like and subscribe to my channel. So it's Fun Text with Hashan. And I'll see you in next video where we patch this exe by using the assembly instructions. So until then, have a nice week and goodbye.